slightly different. You've got thick, so you've got whole things. There's all my parts automatically. I've done an assembly already. What you do is you select all those parts. Tall post is the first one, it's the anchor part, okay? And then you put all the other ones on after. I'm going to highlight some. I'm going to go put part on, making sure the tall post is the first one I capture, and it automatically just drop them on there for you. It'll automatically line up as well. So, browse, component, browse, and I'm going to, right, what I'm going to do, I'm going to go like this, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'll put those into there. Hopefully, is it going to do it? No, it's going to do it. Browse, that's CAD, okay, under there. CAD 1D, Georgia Balls. Let's have a look. Well done, Georgia. So browse, have a look, cancel, browse. Let's go and get parts. Here we go. Ready? If I show you this, let's go. I'm going to go that one. That one there. If you notice, tall post comes up like that. Okay, beautiful. And it automatically lines up. As you can see, this one's not quite correct. Okay, it's done by one of my students last year. It's just good for doing assembly anyway. Didn't quite actually hear my voice. So what you do is you go and insert all the other components. Guys, when you're finished, thank you. I really want to get this done. We have time's not on our side. And open. I'm going to open all of those in one hit. Watch this. Fail to open. That's shocking. There it is. Okay, and then what I can do. Ready? Watch this. Drag and drop all of them. 1, 2, 3, 4. And so look, 5, 6, 7, 8, and should have all. So I've got all those bits on. We need 2 of these, don't we? And we need 2 of those, and we need the lead screw going through the middle. Am I right? So let's have a look, see if we round these, insert components. Let's have a look what we haven't got. And let's do it if we do visualise. Visualise, okay, visualise these. Let's have a look, see what we've got. Adjusting screw, I think it's that one, is it? Adjusting screw. Is it that one? I think it's number 5. Failed to open for some reason. Let's have a look. Browse, and I'm going to do this. Let's search on here. Let's go up. Josh Lee, Mr. Floria. So look, see if he's got it. Oh, look at that, it's gorgeous. Just like that one is the one I want. On that one, open it, pop it in there like that, it goes into here. So you've got 1, 2, 3, that's good. The adjusting nut, that nut, okay. So you've got the washer. Right, we've got that one. We need 2 of these, don't we? So we need a number 4 and a number 7, I do believe. So let's have a look. Insert components. We need that one. Okay, so we insert 2 of those. And the other one we can insert, let's have a look, not that one. Bolt, no. Not that one. He's got a 2-post screw, here we go, insert, look at that, that's beautiful. That one's, I think, wrong, so let's delete that one, yes. Put 2-post screw in, insert 2-post screw, where is it? Beautiful. Now, let's assemble this, let's put it together. First thing we do, put the large stem which goes into the base first. And when we assemble this, so I'm going to do that one into there, and that holds the actual thing onto the keyway of the tall post on the actual side plate. So you're putting this onto a milling machine, and you're actually screwing it onto there, so you need a post to go in there, that goes on top, and you screw it down the angle you want. Okay? So what we're going to do is, when these people stop chatting, they're going to get kicked out in a minute. 3, 2, 1. Okay? I'm going to use a few commands. I'm going to use coincidence, I'm going to use parallel, concentric, okay, and distance probably. So what I'm going to do is I'm going to go, right, that one happens to be concentric with a central hole there, like that. Okay? You can see that now slides up and down that actual hole in the middle for the central column hole and that. Notice it's free flowing. What I do is rule of thumb. This is, and you notice, it doesn't matter if it's, guys, I'm trying to teach you how to do this assembly. Okay, you're chatting over me and it's making my life difficult. I don't want to have a sore throat. I've done 3 hours teaching this afternoon. Unless you want to do start from this lesson and I'll go Christmas shopping. I don't mind. Alright? Thank you. Now, this is in millimetres, doesn't matter if it's millimetres or inches. Do a distance between there about, I'd say about 3/8 of an inch, 8 mil or so, because that way, when it comes up the top of the tall post, you've got to have, when you put bolts on, and this is good practice, you always have a little bit of thread protruding to show you're doing maximum grippage on that, okay? If you see someone out in a workshop anywhere in your industry and they've got it and their thread doesn't pop out, it's only halfway through the nut, you tell them to change that and make sure it goes through so it's actually anchored in properly. Some people's lives might depend on it. And if that nut blows off, you could kill people. Okay, especially in aerospace, British on high-speed rail, you've got a train doing 115 miles an hour. I mean, evidence has been clear in accidents in Britain, and that sort of lapse of days call some, oh that'll do, doesn't matter, I'm going home, watch football, attitude. You can't do that. You're responsible, you're engineers, people's lives are in your hands. So you've got to do it properly, alright? So what we're going to do is, we're going to do a distance, 8 millimetres, from there, so I'm touching that base there, it goes Cambridge blue, and onto the base bit there, okay it, and if you look, there's enough thread sticking out for me to put the washer and everything on. Let's put the washer on. So what I'm going to do is I'm going to get this, and I'll move this manually up to there, and I'll make it concentric so it's in alignment. So I'll go like that, tilt it over, concentric, use the bottom edge, and use this bit in here, like that, it pops on. And it moves freely up there, again, concentric, use coincidence underneath, bottom of the washer at the top of that, so it's locked into place, it doesn't move, okay? So it won't go in X, Y, or Z, or X, Y, or Z movement, it's stuck on there. Okay, same with the nut, let's put the nut on. Let's find the nut, okay? Let's see if we can do the same with this one. We're going to go concentric. I'm going to go that circle there. And I'm going to do it with this one here. Perfect. Make sure it's coincidence again, so you lock it in place, so it doesn't move. And we can do this, beautiful. And then we just do the rest of it. So let's do this wedge. And we get the wedge in, and I'll show you how to do that so it goes in perfect. We're going to go parallel, that face, with this face, and turns it round. Okay. Coincidence. I just happen to know that this middle point here, the no point on the edge, happens to be coincidence with this bit, and it fits perfect. If you notice, this is actually midpoint between those. It can move up and down and undulate, and I'll show you how to actually lock that out. Right? What you do is you put that parallel, the surface there, the top edge, parallel the underneath, and it'll lock it like that, so it doesn't move. Then you can put the other stuff on. So you see you're building it up, just build it up slowly, bit by bit. Now let's put this in, let's have a look. So we put these in, we'll do this one first. Click on there, it's got to be parallel with the underside of that. That locks it in place. Let's put these screws in, these set screws in, these bits in there. Again, concentric, select on there. This is a bit tricky, select on that one. It's gone all the way down, doesn't matter. You can pull this all the way up like that. And what we can do, we can use the bottom bit to actually lock it in place. Let me clear this. Pull that down. And we use the bottom of the actual this bolt to go into there. So I'm going to go coincidence. This one is coincidence with the top of that, and it's locked in place with enough thread either side for adjustment. You can, in assemblies, if we get proficient in this, you can actually put one of those in, and then what you can do is actually do a linear pattern of that, because you know the distance between centres. Benefit of it is if you decide you want to adjust these for any reason, or you want to move them out to do an exploded view, they move synchronously. And same if you're doing like valve stuff, you want it so that they stay in position, they go out in synchronicity when you put it out for exploding, for assembly. It helps you a lot, it saves you a lot of backup time. I'll just do it manually for this one. Let's do the other one quickly. Quick one again, into there, into the top, and it goes in, like that, okay it. Coincidence, the top one. So remember guys, it's the top one, ladies and gents. We're young engineers, okay. So, when it do it, that one happens to be coincidence with that one, in it goes. You can do kinematics for this, and if anyone doing the degree, learn the kinematics, and you can get the harmonics, and then understand how the components you design will behave in real life before you build them. It's a real money saver, and that is the sign of a proper metal or aero or electrical engineer. Okay, really, really good. So that's okay like that. Pull that one over there, that one over there. This one comes down here, let's have a look, see if we can put that down there. Now, let's do this. Let's do it and B&Q it. Let's put this one in first. Clear? So I'm going to go, see that? That bit just happens to be concentric with this bit. Let's paddle it. Over down here you've got paddles, turn it round. And then, let's have a look. So, this bit here needs to be coincidence with the other bit. Coincidence, that edge there just happens to be coincidence with that edge there. It goes flush. You don't want that, that has got to be flush. You don't want it to stay in proud because it's got a counterbore on there for that reason. Because when the guys put it on the tool post, if you've got something a bit protruding, someone's not saying, sometimes you get those screws and they're not finished properly, someone gets a cheap batch of screws, it'll slice through your finger, you run into it, next thing you know there's tomato sauce all over the machine and you've got to fill out an accident report. Okay? I've seen that done in Paramount Sheep down the road here. Like, we've got some bolts and that. It's doing up the fixture on a pillar drill, on a large pillar drill, and he went like that, he thought it was okay, he jarred a bit, and the bolt wasn't finished, he sliced his finger down there. The amount of blood, I mean, he didn't need tomato sauce for his sausage sandwich that lunchtime. Not a pretty sight. You guys won't do that, will you? Now, I'm going to show you tricks of trade. Parallel, that face there is parallel with that, and it turns it over so it's actually it's tilted over like that and turn it so it's nice and straight. Okay? It's just a little bit of slab on. Okay? All good so far? Any questions? 3 commands, 4 commands?
Yeah, that's all right. Yeah.
So what I'm going to do is I'll put on the where is it? Where's it gone? That one, the recess. Right? Make sure the recess one is the correct way round. I'm going to do it as again concentric. This one concentric with. I mean, you can do the end of. You can actually be naughty if you can, and do the end of this. If it takes it, let's have a look. It won't take it. What a rascal. So that's to do the back end. I'll do the back end. Concentric with that. Beautiful. Now it does move along there because it's free to move. Okay. Now that one's the wrong way round, isn't it? Am I right?
Yeah.
So what we can do is we can undo that. Do it again, and then use the paddles. If you see it's the wrong way round, but you've got it in the correct locality, like that, use these paddles over here at the bottom, and it actually turns it around on itself. So it's saves you having to do the command again, and it saves you a lot of parts like So watch that one, if you look at that, there it goes, turn it around, flick it around on the axis for you. And you know the details are still locked in place. So now, coincidence, okay, that one with that face, beautiful, and then you do this one, concentric. Now you can use the actual recess one as a reference so it doesn't go into the body tool post. which is nice and neat. So I'm going to do concentric, this bit with this bit, and now coincidence, that face with that face. Marvellous. We're nearly home and dry. That's most of the tall post assembled. Now, a little trick of the trade, because that's threaded all the way along, it's really difficult if you've got one of those full threaded sections to actually get it to actually line up to be concentric. So what I did is told these students to put a little pit mark on the back of it, click on the surface, put the minutest of extruded holes, doesn't have to be big, and what you can do is use that reference to get it to line up and then put it in the back there. Otherwise you're going to have loads of heartache chaps. So it's a little trick of the trade there, and it doesn't affect the structural dynamics of the component, okay, because it's hardened and heat treated. So let's do this again. Concentric, I'm going to do that little hole, it's very small, okay, it's a bit like my wages. You go to here, you just click onto there like that. You reverse it, paddles, there it goes reversed, you see that?
Yeah.
It saves you a lot of bag, but you've got it in position. And now what we do, this is the best bit. Coincidence, touch on that face there, and then just touch on the triangle face there, and it does it for depth automatic, so that should be just protruding a little bit, so you can get your drive for it, and that's so, you know. All good?
Yeah.
And I'll do another one, and that's the assembly done. Once you've done that, save it, make a drawing of it, and then I'll show you tricks of the trade. You actually do 2 drawings, but it only has 1 file. So you have an assembly view and 1 drawing, don't have to annotate it, it's assembly, and then you've got click on the second sheet, and then you've got the exploded view, bill of materials and balloons in there, and how many parts are in there. And that looks really good. When you do your projects next year, that's a real nice touch to show professionalism. That's like merit territory for communication skills. Okay? It shows you know what you do. You can design stuff and present it correctly to another engineer. That's like merit distinction area. Okay? I'll just let you into little symbols there. So let's do the other one. Let's do the other one, everyone. Mum's the word. Okay? Concentric. Let's do this one. Let's do the back edge of this one. Goes in, there's paddles, like that, love it. Coincidence, let's have a look. We'll do this, and we do the end, and we'll do this face. Let's have a look at what it looks like. Have a look what it looks like in isometric. There it is in isometric. How good is that?